All right, here we go. So we're going to be looking at how to solve quadratics using the square root. So this might be familiar. We did a little bit of this when we did a study of quadratics way back in Unit 2. And we were looking for maybe like intercepts. But what we're going to do now is just solve for x. Okay, so when we solve for x, what we're doing here is we're basically solving for the roots. All right, we're solving for the roots. We're solving for the x-intercepts. But we're going to be using or applying the square root method. All right, so the square root method is special in that it can only be used in certain situations. Square root method cannot be applied for every quadratic, right? The only time you're allowed to use the square root is whenever you have a set or a parentheses and then a power of 2. But the parentheses and the power of 2 must be by itself on one side of the equation. All right, so we'll take a look at a couple of examples. But as you see here in example 1, this is one of these great cases where it's ready for the square root to be used. Because what I'm trying to do is to get rid of this power of 2. Now, I could expand it, but that takes a lot more work. So instead, what we're going to do is we're going to apply the square root because it's ready for the square root to be applied. And when we do it to one side, we do it to the other. So the square and the square root, inverses of each other, they cancel. That gives us x minus 2 is equal to the square root of 5. Now, it's important to remember something. Whenever you apply the square root to a constant, you also get the plus or minus square root of 5. Okay, and now why is that so important? Well, the reason we need plus or minus is because remember what we started with. We started with a power of 2. So that indicates the number of solutions that we should arrive at. So now, this is how we're going to be able to generate these two different solutions. If we were to use just the positive version, that creates one equation, which is x minus 2 is equal to the positive square root of 5. And then if we were to use the second version by using the negative, we end up with x minus 2 is equal to the negative square root of 5. Okay. Now, square root of 5 is just some number, right? It's a number that we just don't know exactly what it is because we don't know what the square root of 5 is exactly. So we're going to leave it as the square root of 5 for now. But I still need to solve for x. So if I'm going to solve for x, I want to get x by itself, I would need to add 2 to both sides. So on the left side, the 2's cancel. On the right side, this is where it's really important to understand what's happening. Square root of 5 is already a number, okay? But what you're not allowed to do is add 2 and 5 and make it the square root of 7. That's not allowed. Okay, what this is 2 plus the square root of 5. Okay, it's 2 plus the square root of 5. All right. And if we found out what is square root of 5 approximately, we could add it to 2 and we would have an approximate answer. But we don't need to know that. All we care for is give me an exact value. And this is what I mean by an exact value. We leave it as a square root. So it's 2 plus square root of 5. It is not the square root of 7. All right, you're not allowed to add an outside number with a number that's inside the square root. All right, is that clear? All right, so we have one of our solutions. X is equal to 2 plus the square root of 5. Now we need to look for the other solution. The other solution will be very similar because we also need to add 2 to both sides. The only difference this time is that it's 2 minus the square root of 5. All right. So there we have both of our solutions. So one of the ways in which this solution can usually be written is you could also write it as 2 plus or minus root 5. Because that gives you both versions, plus square root 5 and minus square root 5. And those two x values would represent the solution to your equation. They could also represent the roots of the polynomial, which is where it intersects the x-axis. Okay, so what about the plus or minus? The reason why we need a plus or minus is because we need to have two solutions that we're solving for. And the reason why we need two solutions is because we have a power of two. Okay. Now, the reason why it works is basically because if I were to go back and square both sides, let's say that I just had this. Actually, no, it has more to do with just 5 in general. If I wanted to get, if I had, let's say, negative square root of 5, and I just had square root of 5, right? And I were to square, I'm trying to get back to 5. If I were to square this, negative square root of 5 times negative square root of 5, negative times negative is positive. Square root of 5 times square root of 5 would have been square root of 25, and I would have gotten square root of 25 is 5. So do you see how this negative square root of 5, if I square it, gives me 5? But also, if I would have taken square root of 5 times square root of 5, that's square root of 25, and it also gives me 5. Okay, that's why we need the plus or minus, because it could be either one. But primarily it's because when we're solving a quadratic, if I apply the square root, I need to end up with two solutions. If I don't use the plus or minus, I would have only arrived at one solution. And then I would have another solution that's missing. All right, so that's why we apply both the plus and the minus square root. But if it's a plus or a minus, it doesn't matter. It just means that it's a positive square root of 5 or it's a negative square root of 5. That's all. All right, let's move on to number 2. So number 2 has a similar setup. What's nice about it is that you do have the parentheses squared on the left side by itself. There's no extra constants or coefficients that we need to worry about. So when you have a scenario like this, it's ready for us to apply the square root to both sides. So we arrive at x plus 3 is equal to plus or minus the square root of 8. All right, now, the square root of 8 is a number that can be reduced. And we talked about this last time. Square root of 8, if you break down 8 using a factor tree, you get 4 times 2. And then 4 can break down into 2 times 2. So when you're using square root, remember that you're looking for a pair of numbers. So I have a pair of 2s, and I have 1 2 that's left over that would go back inside the box. So I can rewrite plus or minus, the square root of 8 is actually just 2 root 2. Okay, it's 2 times root 2. And I have x plus 3 is equal to 2 plus or minus 2 root 2. Remember that then we can split this up using 1 as the positive version. So we have x plus 3 is equal to the positive 2 root 2. And then we have the negative version, which would be x plus 3 equal to negative 2 root 2. Okay. So I want to get x by itself. I would have to subtract 3 from both sides. So that would give us x is equal to, once again, the trickiest part when you have these these square root values is to try to think of it as like, oh, that 2 and that 3, I could just subtract it and say that it's negative 1. Again, that's not the case. 2 root 2 is already a number. It's some value. It's some decimal that we just don't know the value of right now. So the way I would need to write this is to say, okay, well, it's minus 3, but then there's a positive, so we're adding 2 root 2 to that negative 3. So the value is negative 3 plus 2 root 2. All right, this is my answer. And then that means then on the other side, if we subtract 3, that gives us x is equal to negative 3 minus 2 root 2. So x equals negative 3 plus or minus 2 root 2. This would be my solution. Yes, the thing I do to the 8, the thing I do, it's simplifying. Right? We're simplifying the root. Any questions on example number 2? All right. Any other questions so far? All right. I'm gonna do one together, and then I'm gonna have you guys try one on your own. All right. So here we go. Example 3. Once again, the setup is nice. It has the parentheses with the power of 2. All of that is by itself on the left, equal to some constant. So let's go ahead and apply the power or the square root to both sides. Square and square root. That allows us to bring down 5x plus 4 is equal to the square root of negative 36. Now, we learned about this. The square root of negative 36, if there's a negative inside of the root, it becomes root 36i, right? We extract the I. Extracting the I just simply means turning the radical. Whatever number is inside, it becomes a positive, but it multiplies times the value of I that is on the outside. Now, what's nice about it too is that now we can actually take the square root of 36. And before I forget, I should have a plus or minus in front of this as well. So it's actually plus or minus root 36 times I. But this can simplify into plus or minus 6i equal to 5x plus 4. All right, so once again here, we're going to use the positive version for one equation and the negative version for a different equation. So we have 5x plus 4 equal to 6i. We want to solve for x, so we're going to subtract 4 from both sides. 5x is equal to negative 4 plus 6i, right? See how one value is imaginary, one number is a real number. They don't mix, right? You can't say, oh, negative 4 plus 6, make that 2, and it's 2i. Doesn't work that way. They have to stay separate. So it's negative 4 plus 6i. And then I still need to find my x value. So I would have to divide both sides by 5. So my first solution would be x equals, write it up here, x equals negative 4 plus 6i all over 5. And then we would split it for using the negative value. So we have 5x plus 4 is equal to the negative 6i. So we solve for x by subtracting 4 from both sides. That gives us 5x is equal to, is that negative 10i? No, right? One is a real number, one is an imaginary number. They don't combine. So we just write it out as negative 4 minus 6i, and then we divide both sides by 5. So my second solution would be x equals negative 4 minus 6i divided by 5. Okay, so you can just box them up separately. And those are my two solutions to this quadratic. So if you look at my solutions, these solutions are imaginary because they have the imaginary unit I, right? Before my other solutions, those were real. Okay, they were real numbers. The 6 is because the square root of 36 is 6. Once I extracted I, then it's just square root of 36, and I can take the square root of 36. Yeah, that's correct, Nelson. You could also write it as x equals negative 4 over 5 plus or minus 6I over 5, right? They both need a denominator of 5 if you're going to do it that way. Or it could be x equals -4 plus or minus 6I all over 5. All right, so these would be two correct ways of writing the condensed version right here. All right, any questions on example 3? Yes, there's two answers. Remember, it's supposed to be 2 because we have power of 2, which indicates the number of solutions we should have. It was 2 answers, but I condensed it. So if you go back, right, this is one solution. This is the second solution, but then I would just condense it. You see how I use the plus minus here? I condense how I write my solution, but it's still two separate answers. You don't have to condense it. No, no. But you should be aware that if you see it that way, it's describing two different solutions. But on the test, you can leave it separated. But like SBAC, SAT, sometimes you get solutions and they use it this format where it's condensed. So I want you to be familiar with it. All right, I want you guys to try example number 4. Okay, so I think we agree that it's already set up nice in a way where we can just go ahead and apply the square root on both sides. So let's go ahead and do that. If we do, that allows us to then cancel out. That leaves us with 2x minus 3 is equal to the square root of 100 I. Right? I gets pulled out, extracted out of the square root. But since we need two solutions, don't forget you need a plus or minus. And the square root of 10 is actually something that we know. So we would actually get plus or minus 10I equal to 2x minus 3. Okay, so then we need to solve for x. So we would go ahead and add 3. Or actually, before we do that, right, we can always split up our equation. 2x minus 3 is equal to just positive 10I. And then the other one would be 2x minus 3 equal to negative 10I. We would add 3 to both. So we get 2x is equal to 3 plus 10I. And then we would have to divide both sides by 2. So there was a debate as to, do we turn that 10I into a 5? The answer is yes, because if I divide both sides by 2, it's also the same thing as saying I'm going to divide each of the terms by 2. Okay? So that gives us x is equal to 3 over 2 plus 10 divided by 2 is 5. So we have 5I. And now we can do the same on the other side. So we add 3 to both sides. 2x is equal to 3 minus 10I. And we divide both sides by a 2. So that's the same as dividing every term by 2. So your x is equal to 3 over 2 minus 5I. So if you wanted to condense the solution, you have 3 over 2 plus or minus 5I. It still exists because 10i and 5i, they're still imaginary values, right? You're not going from imaginary to a real. You're staying imaginary, but you can still divide 10 by 2. So we reduce that as it's just 5, right? Because it's 10i to 5i, not 10i down to 5, right? If you're jumping from imaginary to real, then there's some issues. All right. But that's good. That was a good debate you guys were having. Now you know. All right. Any questions here on number 4? So could number 3 be divided further? Yes and no. Number 3, you can't divide these values by 5, right? They can't be reduced any further because you're dividing by 5. Okay, but it depends on the denominator, right? This one obviously can't reduce any further. You can't reduce this one any further. Yeah, you could. So you see how I wrote it in a condensed way up here? That is one of the ways that it could be written, right? But you can't go any lower than that, right? Can't reduce 6 by 5 or 4 by 5. All right, let's move on to number 5. Oh, this should be equals. Sorry. Let's try this one out. Once again, it's ready for square rooting, okay? Because you have the parentheses and the power of 2 on the left side by itself, okay? Let me give you a little example. I'm going to still do the same problem, but let me just show you an example of where it's not ready to be square rooted. Now this problem is not ready to be square rooted. The simple fact that it has a constant means that we would have to first move the constant and then it would be ready for square rooting. You guys see the subtle difference? Yeah. But in this case, because that's not there, right, and the original problem is just equal to negative 18, then we can just jump right into the square roots. So we apply the square root to both sides. Square and square root cancel. 1 over 2x plus 1 comes down. And that's equal to the square root of negative 18. So it's going to be plus or minus the square root of 18i, right? Square root of 18i. 18 is a number that we can reduce or simplify using a factor tree. So we take 18. Nice factors for 18, 9 times 2. Because 9 times 2 gives us, well, we factor the 9 down into 3 times 3, and now we have a pair with only one term left in the box. So the square root of 18 simplifies into 3 root 2 I plus or minus equal to 1/2 x plus 1. So let's go ahead and solve this one. Split it up into the 2 different types, one using the positive. Actually, you know what? Instead of splitting it up, let me show you how you could do the same thing without splitting it up, and you still get the same solution, okay? This will actually save you some time, save you some work, because that way you don't have to do it twice, all right? What you can do is you can keep the structure with the plus or minus. You still solve for x. So we would subtract 1 on both sides. And what we have is 1/2 x is equal to negative 1 plus or minus 3 root 2 I. And then I need to find a way to get rid of this 1/2. What could I do to both sides to help me get rid of this 1/2? Yeah, we can multiply by 2, right? Multiply everything by 2 on the other side. So 2 times 1/2 Well, 2, they cancel. So we're left with just x. On the right side, make sure you distribute. So you're going to distribute 2 times -1, so that gives you -2, plus or minus. What you are allowed to multiply is the coefficient with 2. So it's actually 3 times 2, so that's 6. But the root 2 does not get affected. Okay. The idea that you don't multiply or add with numbers inside of a square root must stay that way. But you are allowed to multiply with the 3 because that 3 is just a coefficient. So we can multiply the 3 times the 2, that's how we get 6. So check it out. There's my answer, and it's already in a condensed way. -2 plus or minus 6 root 2i. It's another imaginary solution. And both of my solutions are in there, right? Because I have the plus and because I have the minus, that's what indicates that we have both. Any questions on number 5? Epic. All right. Radical. All right, now this one, leave it for last because you can see how much needs to be unpacked before we can even apply a square root. Everything before was just getting used to the idea of apply the square root, simplify the constant if you need to, use a factor tree, right? We threw in I, we threw in plus or minus. Now it's like, well, we're not even there yet because I have a denominator of 4 on the left side. I also have a constant of +1. I have a coefficient of 3. I'm not anywhere close to being able to just apply a square root. So we have to unpack this. We have to first get the parentheses squared by itself. That's the goal. We need this by itself. Everything else we need to find a way to get rid of. How do we start? Well, first let's get rid of the denominator of 4, right? So we can multiply everything by 4. So if we multiply the right side or the left side by 4, that's going to help us get rid of it. And we multiply the right side by 4 as well. So 4 over 4, that just leaves us with 3 times 5 minus x squared plus 1 equal to 7 times 4 is 28. All right, what could we do next? Yeah, let's subtract 1. That leaves us with 3 times 5 minus x squared is equal to 27. And then after that, yeah, we can divide both sides by 3. So now we're in a position where 5 minus x squared is equal to 9. Now we can do some work, right? Now we can apply the square root. So let's go ahead and do that. This gives us 5 minus x is equal to 3, because the square root of 9 is just 3. And I need my plus or minus. Okay. So I'm going to split this one up. I have 5 minus x equal to 3. And I have 5 minus x equal to -3. Now we just solve for x, right? Solve both of them for x. We can subtract 5 from both sides. -x is equal to -2. But we don't want -x, we'll just divide both sides by -1. So that x equals 2. On the right side, subtract 5 again. -x is equal to -8. And then divide both sides by -1. So x equals a +8. So your two solutions are x equals 2 and x equals 8.